Imagine a time when our world was vastly different, a time of ice ages and mammoth hunts. Our closest extinct relatives, the Neanderthals, roamed the earth. But how did they adapt to such harsh conditions? How did they interact with early Homo sapiens, and what ultimately led to their disappearance? What if language wasn't just our human superpower? Could the Neanderthals have had voices of their own? Today, over 7,000 languages bring the world to life, each a unique blend of sounds, rhythms, and expression. A true marvel of human evolution. Language is one of our most defining traits, setting us apart from any other species. But what if we weren't the first? Nearly 400,000 years ago, Neanderthals roamed Europe, adapting to harsh landscapes and building lives in ways that might surprise us. Resilient, resourceful, and possibly more like us than we realize. Could they have had a language of their own? Did they speak, connect, and share thoughts as we do? Let's dive into this fascinating question and unravel one of the greatest mysteries of our shared history. Before we dive into what the Neanderthals' language was like, we first have to know who they were. To put it simply, Neanderthals were an ancient human species, our closest relatives, who thrived in Europe and Western Asia from around 400,000 to 40,000 years ago, known for their powerful, stocky build and distinctive features. Such as prominent brow ridges and large noses, Neanderthals were well adapted to the harsh Ice Age environments they inhabited. They were skilled hunters, toolmakers, and surprisingly resilient survivors, capable of enduring extreme climates and diverse landscapes. But there's more to Neanderthals than physical strength. Genetic research has shown that they occasionally interbred with Homo sapiens, leaving traces of their DNA in modern humans. And while their reasons for eventual extinction remain a mystery, one thing is for sure: if we can crack the Neanderthals, then we are on our way to finally understanding who we are and why we are who we are. So bringing it to the topic of complex language, we first have to define what we mean by this. When we speak of complex language, we're referring to the ability to convey abstract ideas, emotions, and detailed information through structured grammar, syntax, and vocabulary. This level of communication enables not just basic interaction, but the sharing of intricate thoughts, plans, and cultural knowledge across individuals and generations. And perhaps the first place to look to answer this question is the usual suspect when it comes to ancient humans, genetics, and physiology. Fossils today stand as one of the most famous and important gifts we got from our ancient ancestors. But the Neanderthals may have left us more than bones, as their physical structures carry hints of a possible language. Let's start with the vocal cords. The vocal tract is the passage in the body through which sound is produced, extending from the vocal cords into the larynx, aka voice box, up to the mouth and nasal cavity. It includes the pharynx, mouth, tongue, and lips, which together shape the articulate sound. Essentially, when air from the lungs passes through the vocal cords, it creates vibrations that resonate within the vocal tract. It is by adjusting the shape and movements of these parts that we produce different sounds and speech patterns. So what were the Neanderthal vocal cords like? The shape of the Neanderthal vocal tract has long been a subject of intense study. Unlike the elongated, flat vocal tract of non-human primates, Neanderthals have an arched skull base, more similar to modern humans. This arched structure impacts the shape of the throat and vocal cavity, potentially allowing Neanderthals to produce a broader range of sounds. However, there are some differences between ours and theirs. For example, their vocal tract might not have been optimized for the full array of sounds that modern humans can produce, particularly in high-pitched or complex tones. Regardless, the structure suggests they could make a variety of sounds beyond simple grunts, such as basic vowel and consonant combinations, setting them apart from their primate relatives and positioning them closer to the communication abilities of early humans. Besides the vocal cords, another necessary feature for speech is the hyoid bone. Found in many animals, the hyoid bone is a small U-shaped bone in the neck, located between the chin and thyroid cartilage. It supports the tongue and is crucial for speech, swallowing, and breathing. By anchoring muscles involved in vocalization, it enables complex sounds, making it essential for human speech capabilities. So, did Neanderthals have a hyoid bone? Yes, they did. And one was even found in Israel's Kabara cave. And get this, it was remarkable. In most mammals, the hyoid bone is simple and, as such, limits the range and control of vocal sounds. But in both modern humans and Neanderthals, the hyoid bone has a specific shape that supports the more intricate tongue movements necessary for speech. For years, the discovery led many to assert that Neanderthals likely possessed the capacity for spoken language. However, subsequent studies revealed that hyoid shape alone doesn't confirm language. After all, certain animals like pigs possess similar hyoid structures without advanced vocal capabilities. Therefore, while the hyoid shape alone isn't definitive proof, it forms part of a larger puzzle, one that, when combined with other anatomical clues, supports the idea of a more complex vocal system in Neanderthals than initially assumed. Another piece of this large puzzle is the structure of Neanderthal ear bones. This is because this structure provides us with a key piece of evidence to either support or destroy the Neanderthal language theory. Here's why Neanderthals show adaptations in their middle and inner ear that align with those of modern humans, particularly in sensitivity to sounds in the 2 to 5 kHz range, which, by the way, is home to many of the higher frequencies crucial for distinguishing consonants. Essentially, consonant sounds like P, T, and K require precise hearing to differentiate, and these sounds form the foundation of complex human languages. Now, this is where things get technical. See, this adaptation implies that Neanderthals may not only have been capable of producing speech-like sounds, but also of perceiving subtle vocal distinctions. Basically, the ability to hear in this range suggests they could have understood more complex sounds, facilitating the potential for nuanced communication. On the flip side though, primates lack this higher frequency sensitivity, telling us that there was a distinction between primate communication and Neanderthal communication. Now, a lesser known but vital piece of evidence for Neanderthal language comes from the examination of the foramina in Neanderthal skulls. To keep us on track, the foramina are small openings or holes in bones through which nerves, blood vessels, and other structures pass, allowing essential communication between different parts of the body and supporting vital functions. These foramina, which were notably large in Neanderthals, suggests that they had greater control over their breathing, which is critical for speech. That's because controlled breathing is essential for producing steady, flowing phrases and controlling volume, pitch, and cadence, all of which are vital to human speech. In modern humans, controlled breathing supports language by allowing us to produce extended utterances, control pitch, and modulate tone to express meaning and emotion. Today, studies have shown that the Neanderthal nerve canal size appears to be similar to ours, hinting at a possible parallel in their respiratory control. This capacity would have allowed Neanderthals to maintain a controlled flow of air through their vocal tract, essential for producing strings of sound and potentially even intonation, a key element in conveying emotion or emphasis. While the physical structures alone don't confirm that Neanderthals used a language as intricate as ours, they suggest the presence of both vocal capacity and auditory sensitivity necessary for complex communication. Moving away from biology, the Neanderthal paintings actually paint a much bigger picture, as they hint at Neanderthals being capable of more than just simple sounds. At the moment, whether their anatomy amounted to a full language or a sophisticated form of proto-language remains unknown, but the anatomical findings suggest that Neanderthals were far from silent, and their voices, though lost to time, may have been capable of expressing a rich inner world. But for us to truly understand, we have to go to the seat of consciousness and knowledge and dissect the Neanderthal brain. Stay tuned, because it gets very interesting. Above all things, the Neanderthal's brain offers a window into their cognitive abilities and raises fascinating questions about their potential for language. Structurally, their brains were larger on average than those of Homo sapiens, yet shaped in ways that suggest different functional priorities. Key differences include a larger occipital lobe responsible for visual processing and a smaller cerebellum, particularly on the right side. The larger occipital lobe suggests that Neanderthals were especially adept at processing visual information. This adaptation may have been crucial for survival in the diverse and challenging environments they occupied. That's because a heightened capacity for visual processing might imply that Neanderthals relied more on visual memory and spatial awareness than on abstract thought. However, the smaller cerebellum, which is involved in language processing, motor control, and even emotional regulation, could have impacted their ability to manage complex vocal sequences. In modern humans, a well-developed cerebellum is crucial for the fluent, rhythmic speech patterns typical of spoken language, suggesting that Neanderthals may have faced challenges in producing the same range of fluid sounds. Weirdly, language-associated brain regions like Broca's and Wernicke's areas were present in Neanderthals, but it's important to note that these regions alone don't guarantee language capabilities. These areas are also seen in other primates and support a variety of cognitive functions beyond speech. In Homo sapiens, the development of a spherical brain shape may have further facilitated complex language by improving neural connectivity, particularly for abstract and metaphorical thinking. This rounded shape, seen in early modern humans about 300,000 years ago, appears to allow richer connections across regions, a possible factor in the evolution of sophisticated language. Essentially, while Neanderthals had some of the neural architecture seen in modern humans, their smaller cerebellum, distinctive brain shape, and likely limited abstract thought suggest their language, if it existed, may not have had the full flexibility and complexity of human speech. Their communication might have been rooted more in concrete information, physical gestures, and simple vocalizations, rather than abstract ideas or metaphorical language. This distinct configuration of the Neanderthal brain gives us insights into their cognitive world, hinting at a form of communication adapted to their specific survival needs, but possibly less expressive and nuanced than our own. But here's the thing, if we shared genes with the Neanderthals, what role did they play in communication at large? The genetic ties between Neanderthals and modern humans shed valuable light on the evolution of communication, hinting at a shared foundation that may have influenced both species. A key discovery in this topic is the fact that Neanderthals possess the genetic underpinnings for speech, including the FOXP2 gene. This gene is crucial for fine motor control, essential for speech. However, language is a complex trait shaped by multiple genes, brain development, and environmental factors. While the genetic basis for language likely predates the split between Neanderthals and Homo sapiens, it's clear that language is more than just a single gene. Beyond FOXP2, Neanderthals and modern humans share other genes tied to brain development, although it remains uncertain if these specific genes directly impact language. Their existence points to shared cognitive frameworks that might have facilitated some form of communication. The most intriguing evidence comes from interbreeding between Neanderthals and early non-African Homo sapiens. Many modern humans today, especially those of non-African descent, carry traces of Neanderthal DNA, indicating that hybrids were able to integrate successfully into human communities. The survival of these hybrid populations implies that they possessed functional language skills, critical for social cohesion and survival within human groups. Additionally, new insights from epigenetics reveal that gene expression can vary widely, influenced by environmental factors and inheritance. Epigenetic studies have highlighted differences in how genes related to vocal tract development were expressed between Neanderthals and Homo sapiens. For example, specific methylation patterns in these genes suggest that Homo sapiens developed vocal adaptations for more complex speech, possibly missing in Neanderthals. For the less scientifically inclined, methylation patterns refer to the arrangement of methyl groups, which are chemical groups made of 1 carbon and 3 hydrogen atoms attached to DNA molecules at specific sites. This process, called DNA methylation, is an epigenetic modification that does not alter DNA sequences itself, but affects how genes are expressed, essentially turning them on or off. In these patterns, certain genes may be more or less active, depending on where methyl groups attach. Methylation patterns are critical in development, adaptation, and evolution, as they influence traits by regulating which genes are expressed in response to environmental and biological factors. In the end, together, these genetic insights hint at a shared yet distinct capacity for communication. While we may never know the exact language capabilities of Neanderthals, shared genes indicate that they likely had foundational abilities for speech. But now here's the question, just how does the Neanderthal language compare to ours today? Today, linguists and anthropologists likely agree that language did not emerge suddenly in Homo sapiens. Rather, it likely evolved gradually over millions of years through a series of biological and cultural innovations. Now, this theory is quite important as it challenges the idea that a singular genetic mutation was responsible for the sudden emergence of language. Instead, researchers argue that anatomical changes, like the development of the vocal tract and brain structures, along with social and cultural factors, contributed incrementally to the complex communication systems humans use today. In this context, language emerged as a gradual adaptive trait, shaped by both evolutionary pressures and cultural necessities. Now, with that in mind, that brings us to the concept of iconic sounds. For those who don't know, iconic sounds refer to words or sounds that resemble the objects or actions they represent. For example, the word buzz imitates the sound made by a bee, or the word hum that imitates the humming sound. These sounds are quite important, as they are thought to have been the first building blocks of language, building the gap between early vocalizations and more complex words. Researchers believe that early human communication likely began with these types of mimetic sounds. Paired with iconic sounds, the capacity for abstract thought, especially the use of metaphor, is often considered to be one of the hallmarks of advanced language. That's because metaphors allow humans to combine different concepts and communicate complex ideas symbolically. So how do all these tie to our ancient cousins? Some researchers speculate that Neanderthals, despite possessing rudimentary language, may have lacked the full capacity for metaphorical thinking. They believe that their brains, which were shaped differently to those of modern humans, may not have facilitated the intricate neural connections necessary for advanced abstract reasoning. In fact, Neanderthal brains showed a different arrangement of brain regions, particularly in areas related to the frontal cortex, which is involved in planning and abstract thinking. This may have limited their ability to produce complex sentences or express abstract concepts like metaphor, which requires a high degree of cognitive flexibility. Today, anatomical evidence suggests that Neanderthals were physically capable of speech, though their language may not have been as flexible or complex as that of modern humans. So now we have to know, when did we learn to speak? Well, the development of language in human infants provides valuable insights into the evolutionary trajectory of language. Just as early humans likely started with simple vocalizations that gradually evolved into complex language, infants begin their linguistic journey with babbling, producing sounds that imitate their environment. As babies grow, they begin associating sounds with meanings, a process that mirrors the early stages of language evolution in hominins. Iconic sounds play a role in this early language development, as babies often produce words that mimic real-world actions or objects. The gradual evolution from babbling to the use of full words and complex grammar in children mirrors the gradual emergence of language in early human ancestors, including Neanderthals. This process is deeply ingrained in our biological makeup, suggesting that the ability to learn and use complex language is a fundamental human trait that evolved over millions of years. Shifting things over a few 100,000 years into the past, we can actually trace the origin of speech altogether. See, the discovery of a hyoid bone in Australopithecus afarensis, a species that lived around 3.3 million years ago, gives us a critical look into the vocal capabilities of early hominins. Now, here's where it gets truly interesting. In modern humans, the hyoid is shaped and positioned in a way that supports a wide range of tongue and throat movements, which are essential for producing varied speech sounds. However, the hyoid bone found in Australopithecus afarensis resembles the hyoid bones in modern great apes, such as chimpanzees and gorillas. This similarity suggests that early hominins like afarensis might have had a vocal anatomy that included laryngeal air sacs. These air sacs, which are common in many primates, act as resonance chambers, amplifying sounds to make vocalizations louder. While these amplified sounds could have been useful for communication over long distances, they also come with limitations. Essentially, the presence of laryngeal air sacs is known to reduce the clarity of sounds, making it difficult to produce distinct vowels or consonants. This characteristic would have made complex, human-like speech difficult, if not impossible, in Australopithecus afarensis. In this context, early hominin vocalizations likely consisted of loud, resonant sounds useful for alerting others or communicating simple messages across distances, but lacking the fine-tuned clarity needed for detailed speech. These vocalizations might have included calls or screams to convey alarm or territory defense rather than specific words or sentences. However, the development of a more complex and versatile vocal tract structure, as seen in later human evolution, would be necessary to move beyond these early primal forms of communication. Around 2 million years ago, with the emergence of the genus Homo, significant changes in vocal anatomy began to unfold. By this time, Homo species were evolving larger brains, greater social complexity, and increasingly sophisticated tools, which likely required more advanced forms of communication. The anatomical evidence suggests that the vocal tract changes were part of this broader trend towards increased cognitive and social complexity. Perhaps one of the most telling signs of vocal tract evolution appears in our ancient ancestor, Homo heidelbergensis, an early human species that lived around 450,000 years ago. According to studies, reconstructions of Homo heidelbergensis suggest that the proportions of their vocal tract began to resemble those of modern humans, allowing for the production of distinct vowel sounds. This change is important because vowels form the foundation of spoken language. Distinct vowel sounds allow for a wide range of words and meanings, enabling more nuanced communication. Modern humans use a lowered larynx and more flexible tongue to create different sounds, especially vowels, which are essential for intelligent speech. It even seems that the vocal tract configuration of Homo heidelbergensis seems to be a step in this direction, representing an intermediate stage between the less specialized vocalizations of earlier hominins and the articulate speech of modern humans. The evolution of a more human-like vocal tract configuration in Homo heidelbergensis suggests that these early humans were capable of producing a greater variety of sounds, which may have enabled more complex forms of social communication. Although Homo heidelbergensis might not have had language as we know it, they likely had the anatomical basis for more advanced vocalizations, potentially involving rudimentary forms of speech with basic vowel and consonant sounds. But what did all these changes mean for speech in general? These changes in vocal anatomy across hominin evolution suggest a gradual shift towards more sophisticated vocal capabilities. To put it simply, by the time of Homo heidelbergensis, hominins likely possessed a vocal range that allowed for more effective social coordination, potentially giving them an evolutionary advantage in hunting, tool-making, and managing complex social relationships. They both ruled Europe 400,000 years ago, but today, only one can be king. On the left, we have the technologically advanced, large brain, taller and more widely adaptable Cro-Magnon. On the right, we have the specialized hunters with the strength of 10 men, adapted to survive the cold without breaking a single sweat. Who will win? Who survived the longest? And how did these two ancient humans set the course for who we are today? Before going into what could be the most fascinating matchup in all of human history, we first have to look at who Cro-Magnon and Neanderthals actually were. And to do this, we have to rewind the clock to 400,000 years ago, to a time when two separate hominins claimed Europe for their own. Neanderthals and Cro-Magnons represent two distinct human species that coexisted in Europe during what we call the Ice Age. Neanderthals, aka Homo neanderthalensis, were discovered in 1856 in the Neanderthal Valley in Germany. The Cro-Magnons, on the other hand, are an early modern human group, aka early Homo sapiens, and were first identified in 1868 at a site in France. So, point to Neanderthals for being discovered first. But let's move on. Both groups lived in harsh environments, almost unrecognizable from what we call Europe today, and like many of the hominids before and after them, they adapted impressively. Anatomically, the Neanderthals were shorter and stockier, with robust bones and a large brow ridge, adapted for cold climates. Their brains were slightly larger than Cro-Magnons, but their skulls had a lower, elongated shape. The Neanderthals were skilled hunters and used stone tools, although their technology was less sophisticated. They likely lived in small groups and relied on close-range hunting, which most probably led to frequent injuries. Now, the Cro-Magnons, on the other hand, were anatomically modern humans. That simply means they were taller and leaner with more advanced tools, art, and even social structures. Now, this was a game changer because their anatomy allowed for greater endurance and mobility, which helped them adapt to various environments. The Cro-Magnons were a very fascinating group of hominins, as they were even the ones who created the famous cave paintings and various complex tools, demonstrating higher cognitive abilities. So essentially, the two groups were your classic brain versus brawn, And while Neanderthals had strength, Cro-Magnons had innovation and adaptability, which ultimately led to something we will explain more in detail later. When it comes to sheer physicality, Neanderthals and Cro-Magnons were like two different models of human evolution, one built for raw strength and the other for speed and endurance. To make it easier, you can imagine Neanderthals as the heavyweight champions of the Ice Age world, while Cro-Magnons were more like marathon runners or Olympic decathletes, built for versatility and longevity. So essentially, shorter Arnold Schwarzenegger versus Usain Bolt. The Cro-Magnons were the Toyota Land Cruiser of early humans, tall, lean and built for endurance. Their longer legs allowed them to cover vast distances while hunting, which was essential since they were more likely to pursue animals over open plains. Standing around 5'10" or 177 centimeters, Cro-Magnons were taller than Neanderthals and had longer limbs, giving them more agility. This gave them a speed advantage, not only in hunting, but also in their daily lives, and it's all thanks to their anatomy, because their bodies were designed for efficient energy use, much like how marathon runners today conserve energy over long races. This endurance-based strength was more about survival through adaptation than pure power. As such, the Cro-Magnons were the original multitaskers. They developed tools like the atlatl, which, by the way, was a spear thrower, which allowed them to hunt from a safe distance, minimizing injury risks. Essentially, the Cro-Magnons were the sharpshooters, basically the early equivalent of snipers, taking down prey without getting too close to the danger. In every sense of the word, Neanderthals, on the other hand, were practically the bulldozers of human evolution. Their stocky, muscular bodies were a direct adaptation to the brutal, cold environments they lived in. At around 5'5" or 168 centimeters tall on average, they were definitely shorter than Cro-Magnons, but that wasn't a disadvantage because they were packed with muscle. Their wide chests and thick bones, which were denser than those of modern humans, gave them the strength to withstand the harshest conditions. Studies even show that Neanderthals had incredibly thick femurs, which suggest they were built to carry heavy loads. Just think of them as the Ice Age version of professional weightlifters, able to carry the massive carcasses of mammoths or large deer back to their caves. But it wasn't just muscle, because every part of our anatomy evolved for strength. For example, the Neanderthal arms were stronger than we could have ever imagined. Yes, even stronger than yours. We know this because of the evidence of large muscle attachment sites on their bones. This suggests that Neanderthals relied heavily on their hands for tasks like tool-making, hunting, and possibly combat. Studies have even indicated that their forearm muscles were particularly well developed, giving them exceptional strength when gripping objects or handling tools. From a genetic standpoint, Neanderthals had higher muscle mass than Cro-Magnons. Their hands were big and powerful, perfect for close-range hunting and using heavy stone tools. They weren't chasing prey over long distances like Cro-Magnons. They were getting in close and personal, thrusting spears into animals, relying on brute force to make the kill. Basically, they were the action heroes of the Pleistocene, using their strength to tackle wild animals head-on. But this strength came at a cost, because their rugged lifestyle and hunting strategies led to frequent injuries, and their dense bones showed plenty of signs of trauma, like broken ribs and healed fractures, similar to injuries seen in rodeo bull riders today. So while Neanderthals might have been able to lift heavier objects, Cro-Magnons could run further and faster, making them the ultimate long-distance hunters. In terms of life advantages, Neanderthals' physical strength allowed them to survive in harsh conditions where food sources were limited and brutal winters were the norm. Their powerful bodies helped them tackle big games that provided essential calories to keep them alive. However, the Cro-Magnons in the end had the upper hand in versatility. Their leaner, more adaptable bodies allowed them to migrate and adjust to warmer areas, giving them access to more diverse food sources and reducing the likelihood of injury through smarter hunting strategies. In a modern comparison, it's like pitting a bodybuilder against an endurance athlete. Neanderthals could lift more and take more hits. But Cro-Magnons could run circles around them, avoiding confrontation while lasting longer in the wild. But to know which was the best hunting strategy, you have to stick around. For now, let's find out who's smarter. Now, in a hypothetical battle of wits between Neanderthals and Cro-Magnons, the difference between the two species becomes a fascinating topic. On a surface level, both species had large brains, but their cognitive strengths were molded by different evolutionary pressures. Thankfully, modern science can now give us clues to how they might have thought, problem-solved, and interacted with their world. See, regardless of how the media portrays them, Neanderthals had brains that were slightly larger on average than those of Cro-Magnons. But you have to understand that brain size alone doesn't equate to cognitive superiority. In fact, the structure and organization of their brains quite literally reveals the important differences. See, Neanderthals had more developed occipital lobes, the region of the brain responsible for vision and spatial processing. This suggests that their brains were highly adapted for visual tasks and spatial awareness, skills that were crucial for survival in the environments they lived in, an environment that requires navigating dense forests, icy plains, and mountainous terrains while tracking prey or avoiding predators. Science today believes Neanderthals likely excelled in processing visual information and understanding their immediate surroundings, which would have made them incredibly skilled at spatial problem-solving and tactical hunting. Not to mention their ability to assess terrain and memorize landscapes was probably second to none. However, Neanderthals' focus on spatial cognition may have come at the expense of other cognitive abilities. They essentially robbed Peter to play Paul because their frontal lobes, particularly the prefrontal cortex, which is associated with higher-order thinking, decision-making, and planning, were less developed than in Cro-Magnons. This means that while Neanderthals may have been excellent at understanding their environment and making quick, practical decisions in the moment, they might not have been as adept at long-term planning or innovation. On the flip side, the Cro-Magnons had brains that were more evenly distributed in terms of cognitive function, with a more prominent prefrontal cortex. For those who don't know, this part of the brain is crucial for abstract thinking, creativity, and complex problem-solving. Essentially, Cro-Magnons likely had a higher capacity for forward thinking, which gave them an evolutionary advantage in adapting to changing environments. This all relied on their enhanced frontal lobes, which allowed them to strategize not only for immediate survival, but also for future challenges. It meant that whether it was developing new tools, planning hunts, or managing social structures within their communities, the Cro-Magnons were ready. From a scientific perspective, the anatomical differences in brain structure between these two species translated into very different approaches to life. Neanderthals were efficient at solving immediate, concrete problems like how to hunt a large animal, how to navigate through tough terrain, and how to survive in harsh, cold environments. Their tools, while effective, were often utilitarian, showing little innovation over tens of thousands of years. For example, they used similar flint tools for generations, making minor improvements but sticking to what worked, which suggests a cognitive style more focused on efficiency and immediate need rather than experimentation. On the other hand, Cro-Magnons demonstrated a remarkable ability to innovate. Their toolkits were more diverse and sophisticated, including items like bone needles, harpoons, and finely crafted blades. This innovation presents to us a different cognitive approach. They were not just solving immediate problems, but also anticipating future needs. For example, Cro-Magnons developed projectile weapons, which allowed them to hunt from a distance and avoid dangerous close encounters with prey. This shows a more strategic, less risk-heavy approach to hunting compared to Neanderthals' close-quarter tactics. Additionally, social cognition is an area where Cro-Magnons most likely outpaced Neanderthals. This is because Cro-Magnons lived in larger, more complex social groups, as evidenced by the rich artistic and symbolic culture they left behind. They were talking about cave paintings, carvings, and even jewelry. These cultural artifacts actually point to higher levels of communication, social cohesion, and possibly more sophisticated language skills. In fact, the ability to convey abstract ideas through art and symbols suggests that Cro-Magnons had a more developed capacity for abstract thinking and symbolic representation, key aspects of advanced social cognition. In contrast, while Neanderthals did show some signs of symbolic behavior, such as burying their dead and using pigment, these practices were less widespread and not as advanced as Cro-Magnons. Their smaller, more isolated groups may have limited the complexity of their social structures and, by extension, the development of language and symbolic thought. In a battle of wits, then, Cro-Magnons would likely have the upper hand due to their more advanced frontal lobes, which allowed for greater creativity, long-term planning, and social interaction. While Neanderthals excelled at spatial reasoning and immediate problem solving, Cro-Magnon's cognitive flexibility, social intelligence, and ability to innovate gave them the tools not only to survive, but thrive in a rapidly changing world. With that said, the new question is, who was a better hunter? Was it the close combat Hulk Neanderthals, or was it the lean, mean, long-distance hunter, the Cro-Magnon? Stay tuned to find out. Quick pause. If you're enjoying this journey through the prehistoric world, don't forget to like and subscribe. More than 97% of our viewers watch without subscribing, and we'd love to have you join our tribe. It would make all the difference. So, is it done? Great, thanks a ton. When it comes to determining which group were the better hunters, it largely depends on how you define better. See, both species were highly effective hunters, but they had distinct methods that leveraged their respective strengths. Neanderthals, for example, were powerful, stocky, and built for close combat. Their hunting strategy was often centered around ambush tactics, taking advantage of their raw physical strength. With their thick bones and robust musculature, Neanderthals were built to handle close-quarters hunting situations where brute force could be used to bring down prey. Their primary weapons, such as heavy wooden spears, were likely used for thrusting at close range rather than being thrown from a distance. This suggests that Neanderthals preferred to get up close to their prey, whether that meant stalking large herbivores like mammoths or cornering game in tricky terrain. Their environment helped a lot, as it was often harsh and cold, and provided natural landscapes like cliffs and dense forests, where ambushing prey would have been an ideal strategy. Their keen spatial awareness and excellent vision helped them plan these surprise attacks effectively, allowing them to take down large, dangerous animals by overpowering them with sheer strength. However, this hands-on approach came with significant risks, as the injuries seen in Neanderthal fossils, such as healed fractures and trauma similar to those seen in modern rodeo riders, suggests that their hunting methods were dangerous. Cro-Magnons, on the other hand, were more agile, taller, and built for endurance rather than brute strength. Their hunting methods relied more on strategy, distance, and planning. Unlike Neanderthals, who preferred to get up close, Cro-Magnons utilized long-range weapons such as the atlatl, a spear thrower that extended their range, allowing them to hunt from a distance. This decreased the risk of injury while increasing the efficiency of their hunts. Cro-Magnons were the innovators of hunting technology. They developed sophisticated tools like finely sharpened blades, harpoons for fishing, and even traps, showing a deeper level of planning and foresight in their hunting strategies. Their reliance on ranged weapons allowed them to hunt larger game effectively, while also expanding their dietary variety. They didn't have to rely on large animals alone, but could also hunt smaller, faster prey, fish, and even birds with less effort. This versatility was a major advantage in adapting to different environments. Moreover, Cro-Magnons hunted in larger social groups, which allowed them to execute coordinated attacks and drive animals into traps or ambushes. This teamwork, along with advanced communication skills, gave them a tactical edge. They didn't just react to their environment, they shaped it, using fire to drive prey or building complex traps and pits. So if we define better in terms of brute strength and close-quarters hunting, Neanderthals were the champions. I mean, their powerful builds, ambush tactics, and physical resilience made them incredibly effective at taking down large prey in the cold, harsh environments they thrived in. However, this method was high risk, and their hunting was more of a one-on-one battle with the environment and prey. But if better means more efficient, versatile, and less prone to injury, Cro-Magnons take the crown. Their ranged weapons, team-based strategies, and ability to hunt a wider variety of animals with less physical risk made them superior hunters in terms of long-term survival. Not to mention their innovation allowed them to adapt to changing environments and hunt more efficiently without the same high costs Neanderthals faced. In essence, Neanderthals were like heavyweights going for a knockout punch, while Cro-Magnons were more like skilled tacticians, using speed, strategy, and technology to outsmart their prey. So, depending on your preference, brute force or finesse, each species had its strengths in the hunting arena. So, while you tell us who were better hunters in the comments section, let's talk about who won the survival race in the end. To answer the question simply, ultimately, Cro-Magnons were the ones who won the survival game, while Neanderthals went extinct around 40,000 years ago. However, the reasons behind this outcome involve a mix of factors, like adaptability, social structures, and the environmental changes. Let's break down how this happened. Neanderthals were robust and physically adapted to cold climates, which served them well for hundreds of thousands of years across Europe and Asia. They were built for short-range hunting in harsh glacial conditions, with thick bones and powerful muscles that allowed them to hunt large, tough prey like mammoths. They used close-range tools, including heavy spears, which worked well in their environment. However, this strength was their downfall, as it was tied to their ability to survive in cold, specific ecosystems. As the climate began to warm, their reliance on large prey and cold conditions became a disadvantage. The warming climate brought new landscape and prey that required different hunting strategies, but Neanderthals struggled to adapt. While their bodies were perfect for close combat in cold regions, they weren't well suited for warmer, more diverse environments. At this time, their population was already small, and they lived in scattered, isolated groups, which may have led to genetic bottlenecks and reduced their ability to recover from environmental stresses, disease, or competition. Cro-Magnons, however, were highly adaptable. After coming from Africa, they had already evolved to handle diverse environments and climates. Their ability to adapt gave them a significant edge. So instead of relying on brute strength and close-range tools, Cro-Magnons developed projectile weapons like the atlatl, which allowed them to hunt from a distance and target a wider range of animals. They could quickly innovate new technologies to adjust to their changing environments, which allowed them to access more reliable food sources and thrive in different ecosystems. Not to mention, socially, Cro-Magnons lived in larger, more organized groups. This allowed them to cooperate more effectively in hunting and gathering, sharing knowledge across generations, and spreading useful innovations. Their social networks gave them resilience, helping them survive difficult periods where food might have been scarce or their environment changed. So why did the Cro-Magnons win? Well, while Neanderthals were strong and specialized, they couldn't compete with the Cro-Magnons' flexibility, innovation, and social cooperation. Cro-Magnons thrived by adapting to changing environments and developing better tools and social systems. Though Neanderthals left a genetic mark on modern humans, Cro-Magnons ultimately outlasted them due to their superior adaptability and innovation, making them the long-term survivors in human evolution. Everything we thought we knew about our closest ancestors might be a lie. A groundbreaking new study is challenging our understanding of human history. Researchers have uncovered evidence that could rewrite the story of our origins, suggesting the existence of an entirely unknown lineage of ancient humans. This discovery may also shed light on the long-standing theory that modern humans played a direct role in the extinction of Neanderthals. Since it began gaining mainstream attention in the mid-20th century, the idea that humans killed off Neanderthals has become more and more accepted in the science world. For those who don't know, the idea proposes that based on competition for resources, conflict, genetics, and possibly violence, our species directly led to the extinction of our cousins, the Neanderthals. Around 40,000 years ago, Neanderthals and modern humans, aka Homo sapiens, coexisted in Europe and parts of Asia. Both species relied on similar food sources and habitats, something that quickly led to serious competition between the two. As such, some theories suggest that Homo sapiens, with their advanced tools, social structures, and communication skills, may have outcompeted Neanderthals, gradually pushing them out of vital areas. Other theories propose a more hands-on involvement, claiming that direct violence and conflict could have contributed to Neanderthal extinction. This theory is backed up by fossil evidence that shows signs of injuries on Neanderthal remains that could be attributed to human weapons. Then there's the complicated theory of interbreeding. As of now, it is a fact that humans and Neanderthals did interbreed. But the theory goes further to claim that the resulting offspring may have diluted Neanderthal genetic traits over time, leading to their gradual disappearance as a distinct group. This idea, for the longest time, was more or less set in stone. That was until September 2024, when a research team led by Ludovic Slimak, an archaeologist at the Paul Sabatier University in Toulouse, published their new findings of a brand new Neanderthal fossil that changed everything. Named Thorin, he was found in Mandarin Cave in southeastern France and is the first Neanderthal body unearthed in France since 1978. Now, what sets Thorin apart is his unique genetic lineage, which is very distinct from other late Neanderthals in Europe. But we will get onto that later. For now, let's talk about what they found. So far, even though we haven't gotten everything, researchers unearthed an incredible set of remains, including 31 teeth that had the world in a frenzy. This was a big deal because Thorin had 34 teeth in total, and researchers found 31 out of them, including his supernumerary molars, making this fossil the most complete Neanderthal dentition ever discovered. But that was not all, because scientists also discovered jawbone fragments, part of the skull, phalanges, aka finger bones, and thousands of tiny bones scattered throughout the site. But here's the truly thrilling part. This excavation is just getting started. After 9 years of painstaking work, only a small area of 50 centimeters by 30 centimeters, or about 1.64 feet by 0.98 feet, has been cleared. And so, with such a limited portion uncovered, it's almost certain that more of Thorin's skeleton is waiting to be found. The excitement around this discovery is growing with each passing day, and it's only a matter of time before even more of Thorin's ancient story is revealed. But until then, he provided genetic evidence that changed how we think of our family tree forever. Thorin provided a wealth of genetic materials that quickly changed all we know about our distant cousins. Analysis of Thorin's genetic materials reveals that Neanderthals were far from the single homogeneous group we once thought they were. Instead, our long-extinct cousins consisted of distinct lineages that were quite different from one another. Now, this was a game-changer because the finding challenged the long-standing narrative that a uniform Neanderthal population was simply replaced by Homo sapiens around 42,000 years ago. But what was particularly fascinating about Thorin is that his lineage exhibited remarkable genetic divergence from other Neanderthals across Europe, pointing to an extended period of isolation lasting over 50,000 years. In layman's terms, we might have discovered a ghost lineage of Neanderthals, a separated, never-before-seen line of cavemen who might have evolved differently socially, biologically, and psychologically. Simply put, Neanderthals might have had 2 branches on our family tree. If that wasn't groundbreaking enough, his DNA even connects him to Nana, another Neanderthal found in Gibraltar. This was interesting for a different reason, because it indicated that they were part of the same isolated late Neanderthal population, meaning we might have just found proof for this theory. But what does that mean for the Homo sapiens killer theory? The discovery of Thorin essentially goes head-to-head with the Homo sapiens killer theory. That's because this remarkable find gives us a fascinating and previously overlooked glimpse into an aspect of Neanderthal life: their genetic isolation. As opposed to what we initially thought, Neanderthals lived in small isolated groups, cut off from one another, living in their secluded worlds for over 50,000 years. This isolation was a big deal because it likely led to interbreeding, a phenomenon that has significant implications for their survival. But why? Well, when Neanderthals interbred within these limited groups, their genetic diversity began to plummet, creating a narrower gene pool that, in turn, would affect their adaptability. Now, why is this a big deal? Think about it. As the world around them rapidly changed, climate shifts, new challenges, and competing species emerged, these isolated Neanderthal groups found themselves increasingly ill-equipped to thrive. With a reduced gene pool, their offspring were less adaptable to environmental pressures, making survival a serious challenge in an unpredictable world. This means that while early modern humans were forging extensive social networks and exchanging genes, Neanderthals were quite literally bottlenecked in their genetic options. The insights obtained from Thorin's remains, when combined with other exciting discoveries, are at the moment calling for a revolutionary re-evaluation of our perceptions of Neanderthal populations and their extinction. At the moment, we can no longer view Neanderthals through the lens of a single homogeneous group. Instead, we must consider them as distinct communities, each with the potential to develop their own cultures, art, language, and societal structures. For you to understand this, just imagine today's world populated by humans living in small towns, cut off from each other, never interacting with outsiders, never straying from their familiar surroundings. This idea isn't far-fetched, as our current understanding of human history already shows how different regions foster their own languages, cultural practices, clothing styles, culinary traditions, and even genetic adaptations. For example, when we compare Africans and Europeans, we see the rich diversity that emerges from geographical and societal separation. However, for the Neanderthals, this example would be magnified exponentially, leaving us to ponder what their varied societies might have looked like. This emerging narrative paints a vivid picture of diverse lineages and intricate social dynamics among Neanderthals. The findings emphasize an urgent need for ongoing research to unravel the mystery surrounding these fascinating beings and their vital role in our shared human history. We are left to wonder if our previous assumptions about Neanderthals have been misguided all along. Imagine the thrill of considering that Neanderthals lived complex lives, each community with varying genetic backgrounds and cultural expressions. The potential richness of their existence opens new avenues for exploration and understanding, urging us to reconsider what we know about our ancient relatives. And as we continue to dig deeper into their story, uncovering the rich tapestry of their existence, we hope to find not just how they lived, but how they might have interacted with each other and their environments.
Walking the Earth between 130,000 and 40,000 years ago, the Neanderthal is perhaps the most famous species of hominin known to man. From movies to songs and books, their popular persona as cavemen is no new concept. However, who really were the cavemen? Were they as dumb as the media says? And how is it possible that you might have a little caveman DNA in you? Stay tuned to find out. The Neanderthals were the first species of fossil hominin ever discovered, and since their initial discovery, they have grown in popularity, holding a place in the collective minds of science lovers and non-science lovers as the oh-so-popular cavemen. First found in 1829, they were not initially recognized as a possible human ancestor until the second half of the 19th century, when more fossils were discovered. Since then, thousands of incredible fossils representing the remains of many hundreds of Neanderthal individuals have been unearthed from sites all across Europe and the Middle East. These remarkable discoveries include the remains of babies, children, and adults up to around 40 years old. Thanks to these findings, we now know more about this fascinating human ancestor than any other in history. The earliest known Neanderthal remains were discovered by the Dutch-Belgian prehistorian Philippe Charles Schmerling in 1829 in what is now called the Schmerling Caves in Belgium. There, he found a child Neanderthal skullcap named Engis II, along with other skeletal remains that puzzled him. Unable to find a suitable answer, Schmerling believed the remains belonged to a poorly developed human buried alongside extinct animal species. In 1848, the Gibraltar I skull was discovered in Forbes Quarry by Lieutenant Edmund Henry Rene Flint and presented to the Gibraltar Scientific Society. Initially, it was thought to be a modern human skull, and its significance as an archaic human was not recognized until later. Years later, the most famous and pivotal discovery occurred in 1856 in the Neander Valley, near Düsseldorf, Germany. There, quarry workers found bones that included a cranium, thigh bones, and parts of a shoulder blade and ribs in the Kleiner Feldhofer Grotte. Upon seeing the bones, local schoolteacher Johann Karl Fulrod recognized the bones as distinct from modern humans and presented them to the German anthropologist Hermann Schaffhausen for study. In the end, Schaffhausen and Fulrod concluded that these bones represented an ancient form of human, distinct from today's contemporary populations. The species was named Homo neanderthalensis, meaning human from the Neanderthal Valley. Following the publication of Charles Darwin's On the Origin of Species in 1859, Fulrod and Schaffhausen argued that Neanderthals were an ancient form of modern humans. However, their work met significant opposition, notably from pathologist Rudolf Virchow, who insisted the remains represented diseased modern humans rather than a new species. Virchow's erroneous interpretation delayed broader acceptance of Neanderthals as a distinct species until the end of the 19th century. By the early 20th century, numerous Neanderthal remains had been discovered across Europe, solidifying their classification as a legitimate species, Homo neanderthalensis. A key discovery that helped this was the discovery of La Chapelle aux Saints I, also known as the Old Man, in France. Following its discovery, French paleontologist Marcelin Boulay authorized detailed studies on the specimen, and although his work helped the Neanderthal to be accepted as a species of its own, his reconstruction was wrong, as he depicted Neanderthals as slouching and ape-like, reinforcing the image of them as primitive and distant from modern humans. Sadly, the 1912 Piltdown man hoax further misled researchers by presenting a more modern-looking human ancestor, which seemed to support Boulay's depiction. Despite Boulay's influential but inaccurate portrayal, other scientists began to challenge this view. For example, Scottish anthropologist Arthur Keith in 1911 reconstructed La Chapelle aux Saints I as more human-like, with tools and cultural artifacts. And although Keith's interpretation did not gain immediate acceptance, it laid the groundwork for future re-examinations. Thankfully, in the end, the exposure of Piltdown man as a hoax and the re-examination of La Chapelle aux Saints I, whose slouch was due to osteoarthritis, led to a more nuanced understanding of Neanderthals as intelligent and capable, with behaviors and cultures similar to those of modern humans. Today, the Neanderthals are typically classified as Homo neanderthalensis, though some consider them a subspecies of Homo sapiens. Overall, Neanderthals are now seen as a complex and intelligent species, as ongoing research keeps refining our understanding of their place in human evolution. But that's history. The next question should be, what kind of environment would force our closest relatives to evolve as they did? Our closest ancestors, the Neanderthals, evolved and thrived in a world that was anything but stable. The period from about 65,000 to 25,000 years ago, known as OIS-3, was marked by rapid, severe, and abrupt climate changes that had extremely profound environmental impacts. Sadly, despite being physically adapted to cold conditions, the Neanderthals faced extreme and unpredictable shifts in their environment within their lifetimes, leaving little time for their populations to recover. It was this same unstable climate that played a crucial role in their evolution and eventual extinction. Due to their environment, the Neanderthals had to develop a wide range of survival strategies to cope with the extreme conditions. Archaeological records show that they lived in small, mobile groups, which allowed them to exploit different resources and move away from deteriorating conditions quickly. However, the dramatic climate changes of the OIS-3 period would continue to have significant impacts on Neanderthal populations. This is because the harsh conditions at the time caused many local populations to dwindle or die out entirely, making it difficult for Neanderthals to sustain themselves over long periods of time. As time went on, humans adapted, as even small advantages in biology, behavior, or lifestyle could mean the difference between life and death. As the Neanderthals struggled, modern humans arrived in Europe and had a wider range of adaptations, which may have given them a competitive edge over the Neanderthals. Interestingly, evidence suggests that the replacement of Neanderthals was not solely due to direct competition with modern humans, as severe climate conditions made Europe inhospitable for all human populations living there, leading to widespread population declines about 30,000 to 28,000 years ago. However, modern human populations in Africa survived and later recolonized Europe, while Neanderthals, who were not present in Africa, sadly became extinct. The evolutionary history of Neanderthals is complex and intertwined with the broader human lineage. They are thought to have evolved from Homo heidelbergensis, a common ancestor shared with modern humans and Denisovans, before populations became isolated in Europe, Asia, and Africa. The Neanderthals developed distinct features over time, marked by periods of gradual change and adaptation to their environment. In fact, fossils dating back to around 450,000 to 430,000 years ago already show distinctive Neanderthal dental features, indicating the early stages of their evolutionary path. As to how they evolved, two main hypotheses explain their evolution, namely the two-phase model and the accretion model. The two-phase model suggests that a major environmental event, like the Sali glaciation, which was a significant ice age during the Middle Pleistocene epoch, caused rapid changes in Neanderthals. According to this model, first, their body size and robustness increased quickly to adapt to the cold. Then, this initial adaptation was followed by further anatomical changes, helping them survive in those harsh conditions. On the flip side, the accretion model proposes a slower, gradual evolution, divided into stages, each reflecting adaptations to specific climatic conditions. The Neanderthals and Denisovans, another species of humans, are more closely related to each other than to modern humans, suggesting that their split occurred after their common ancestor with modern humans. Genetic studies estimate the Neanderthal-Denisovan split around 473,000 to 381,000 years ago, likely before hominins spread across Europe. These early populations, sometimes referred to as Neandersovans, may have interbred with even earlier human species already present in Europe. Essentially, Neanderthals evolved in a challenging and changing environment that shaped their physical and cultural adaptations. Their interactions with their environment, coupled with their biological and behavioral strategies, were largely successful because of their resilience and adaptability, two traits that truly define what it means to be human. However, the severe and abrupt climate changes ultimately played a significant role in their decline and extinction, paving the way for modern humans to become the dominant human species. So what did these cavemen look like? When it comes to looks and anatomy, the Neanderthals possessed a distinct anatomy tailored for survival in their environment. Their bodies were generally shorter but more robust compared to modern humans, with males averaging around 168 centimeters or 5.5 feet, and females slightly shorter at 156 centimeters or 5.1 feet. The Neanderthals' robustness extended to their muscular build, as they were heavier and more muscular than their modern counterparts. But that was not all, as their brain size was notably larger than that of modern humans, averaging around 1,500 cubic centimeters. This brain size was likely a result of their heavier and more muscular physique, as well as adaptation to cold climates. The distinctive shape of their skull featured a long and low profile, with a rounded brain case, a prominent occipital bone at the back, and a depression for strong neck muscles. The Neanderthals also had thick brow ridges beneath a flat and receding forehead, and their midface projected forward, giving them a distinctive facial appearance. Their jaws were larger and lacked a projecting chin, with teeth that were larger than those of modern humans. They also had robust limb bones with large joints, indicating strong musculature in their arms and legs. Their shin bones and forearms tended to be shorter than those of modern humans, which is typically an adaptation to cold climates. The pelvis of Neanderthals were also wider from side to side, potentially affecting their posture. But that was not all. Genetic studies of the species shocked the world, as they provided insights into Neanderthal adaptations and characteristics, including their unique metabolism, hair, and skin color. According to the studies, they likely matured faster than modern humans, had higher basal metabolic rates due to their muscular build, and were more active in dim light conditions. The Neanderthals had lighter skin to adapt to low sunlight levels, and genetic analysis suggests they may have had a range of hair and eye colors, including red hair and even fair skin. Keeping with the theme of being human, the Neanderthals were not without their health challenges, showing evidence of injuries, infectious diseases, and genetic disorders. In fact, traumatic injuries were common, with a high percentage of specimens showing signs of healed major trauma. But that was not the only problem for the species, as inbreeding may have led to low genetic diversity and increased susceptibility to birth defects and diseases. Disturbingly, there was also evidence of lead exposure in the fossils that suggested there were life-threatening environmental challenges at the time. In order to understand what the Neanderthals ate, we first have to examine their oral hygiene, or more aptly, lack thereof. It should go without saying that the Neanderthals didn't have toothbrushes. This seems obvious, seeing as they were cavemen, but this singular fact was a stroke of luck for today's scientists. See, the lack of prehistoric dental hygiene resulted in teeth gunk that would not only shock your dentist, but also contain a goldmine of information on their diet. But what makes teeth gunk so important and valuable? Well, without regular brushing, a thin sticky film made from proteins and microbes forms on the surface of teeth, known as dental plaque. Over time, plaque hardens to form tartar or dental calculus, composed of calcium phosphate minerals with occasional magnesium or iron. This very process is what gives them their value, as encased within the hard mineral crust, tiny bits of microbial and food matter can be preserved for thousands or even millions of years. Thanks to these bits, scientists can examine the teeth to determine the species of microbes and the types of food Neanderthals consumed. For instance, DNA from dental calculus in Neanderthal teeth found in the Spy Cave in Belgium revealed that they ate meat, specifically woolly rhinoceros and wild sheep. However, for the Neanderthals, this is no one-size-fits-all diet, as what they ate varied by region. For example, in the El Sidron cave in Spain, dental calculus showed a more plant-based diet, including mushrooms, pine nuts, moss, and tree bark. Essentially, the Neanderthals were not exclusively meat eaters. Astonishingly, the dental calculus also provides insights into Neanderthal health and medicinal practices. For example, one Spanish Neanderthal had a dental abscess and carried the DNA of Enterocytozoon bianusi, a gastroparasite. This individual also had DNA of poplar bark, which contains salicylic acid, the active ingredient in aspirin, and traces of penicillium mold, suggesting possible self-medication with natural painkillers and antibiotics. Bacteria encased in dental calculus also do a little more, as they reveal information about Neanderthal microbiomes. See, the Neanderthals had methane brevibacter oralis, a bacterium also found in human mouths, indicating potential saliva exchange between species. Essentially, the moderns might have kissed, or at least shared food with the Neanderthals. A genetic analysis of methane brevibacter oralis in Neanderthals revealed that the ancient versions lacked genes for antiseptic resistance and certain sugar digestions. This basically tells us that Neanderthals had different diets and hygiene practices compared to modern humans. Their diets were less rich in processed sugars, and they didn't use antiseptics, which over time led to evolutionary changes in oral bacteria. As human diets evolved and hygiene practices became more sophisticated, our oral microbiomes adapted, reflecting the ongoing interplay between human evolution and our microbial companions. Now that we know what they ate, the new question is how they lived their lives, and how it mirrors ours today. When it comes to Neanderthals, their way of life was like anything before, and by far strongly showed us the primitive version of who we are today. The Neanderthals likely had the neurological capacity for speech, as evidenced by the presence of the FOXP2 gene, which is a crucial gene for language development. But that's not all, as they also possessed a hyoid bone, which is a U-shaped bone in the neck that supports the tongue, and closely resembles that of modern humans. This suggests they could produce a range of sounds similar to those used in human speech, essentially facilitating complex communication. Perhaps one of the most shocking things about the Neanderthals is that they demonstrated a variety of cultural practices. They engaged in burial rituals, indicating a possible belief in an afterlife or spiritual world, with intentional burials often including grave goods, such as tools and animal bones, pointing to a ritualistic or at least symbolic behavior. Besides believing in religion and having burials, the Neanderthals showed an exemplary mastery over fire. See, fire played a crucial role in the lives of Neanderthals, significantly impacting their survival, social structures, and technological advancements. Essentially, their mastery of fire enabled them to thrive in diverse and harsh environments. For example, fire allowed Neanderthals to cook food, making it more palatable, digestible, and safer by killing pathogens. This enhanced their nutrition and supported their robust physiques. Additionally, the fire provided essential warmth during glacial periods and in cold regions, improving comfort and extending their habitat range. It also served as a deterrent against predators and possibly hostile groups, ensuring safety at night. In terms of technology, Neanderthals used fire to improve their tools, as heat treatment enhanced the quality of stone tools, making them sharper and more effective, while fire-hardened wooden spears became more durable for hunting. Beyond its practical uses, fire was a focal point for social gatherings, facilitating communication, storytelling, and planning hunts. Overall, fire was indispensable to Neanderthal life, shaping their dietary habits, technological progress, and social cohesion. Speaking of hunting, it was a vital aspect of Neanderthal life, essential for sustenance and survival. See, Neanderthals were skilled hunters who used a whole array of tools and strategies to capture prey effectively. Their hunting techniques likely involved both solitary and group efforts, as they employed ambush tactics, stalking, and even persistence hunting, where they would chase prey over long distances until exhaustion. Owing to their robust physique and endurance, coupled with their knowledge of terrain and animal behavior, the Neanderthals were not just hunters, but formidable hunters. To hunt, the Neanderthals crafted sophisticated tools, including spears, javelins, and stone-tipped wooden weapons. They also used sharpened stones and wooden clubs for close-range combat. Today, evidence suggests that they hunted a wide range of animals, including large game like mammoths, bison, and deer, as well as smaller prey such as rabbits and birds. Successful hunts provided Neanderthals with essential protein and fat, supporting their high-energy lifestyle and enabling them to thrive in challenging environments. But that wasn't all, as hunting also fostered social cohesion within Neanderthal groups, as cooperation was necessary for effective hunting expeditions. In fact, evidence suggests they engaged in cooperative behaviors within their groups, such as caring for injured individuals and sharing resources. Besides hunting, the Neanderthals also faced competition from Homo sapiens and other predators, which eventually shaped their survival strategies. In the realm of art, it is believed that Neanderthals engaged in symbolic and artistic activities. They created cave art, including abstract shapes, handprints, and animal depictions. They also had personal ornaments made from bones, shells, and teeth, as well as body decoration and art made from natural pigments like ochre. The Neanderthals were also believed to have enjoyed music, as it is believed they used simple musical instruments crafted from bone or wood to produce rhythmic sounds that resonated within their communities. These musical expressions could have served social, ritualistic, or even communicative purposes. The Neanderthals, much like us today, also saw the necessity of clothing, as they fashioned garments from animal hides and furs, tailored to suit their needs in diverse environments. For them, clothing also served as a form of expression, reflecting individual and group preferences while contributing to a much larger social identity. Essentially, the Neanderthals' life was a complex interplay of group dynamics and environmental conditions. This was also evident in how they dealt with other species, as today, their intergroup relations have shed light on the complex social dynamics of Neanderthal communities. While they likely had territorial boundaries and occasional conflicts, evidence also suggests cooperation and cultural exchange between different groups, as trade networks may have facilitated the exchange of goods, ideas, and genetic diversity, contributing to the resilience and diversity of Neanderthal societies. This intercoordination did not stop there, as the Neanderthals were also believed to have mated with our direct ancestors. Genetic evidence indicates that Neanderthals and Denisovans interbred with each other, as well as with early Homo sapiens populations, as they migrated out of Africa. This interbreeding, however, was a blessing and a curse, as it resulted in the exchange of genetic material between these hominin groups. Today, genetic studies reveal that up to 2.4% of non-sub-Saharan human DNA originates from Neanderthals, while even individuals with sub-Saharan ancestry carry traces from later Eurasian migrations. Today, the Neanderthal genes we carry have bestowed upon us both advantages and disadvantages, as some genes, honed over 300,000 years of Neanderthal evolution, bolster our immunity against local Eurasian pathogens, while others promote fertility and protect against miscarriage. However, some traits, like increased pain sensitivity and susceptibility to certain diseases, may have negative consequences in the modern world. For instance, Neanderthal DNA has been linked to conditions like Viking's disease and autoimmune disorders. Moreover, certain genetic variants increase the risk of severe illness from diseases like the infamous COVID-19, essentially showing us that the complex legacy of our ancient relatives still very much plays a huge part in shaping our health and molding our future. In the end, our closest ancestors are exactly what we call them, as they displayed a lifestyle and adaptation that figuratively and genetically continued to live in us. From appearance to lifestyle, they were the first to truly show what it meant to be human. And it's upon their legacy that we stand today and have built our society. But try as we all might, there is no denying that we all have a little caveman inside us. Roaming the earth around 430,000 years ago, the Neanderthals were perhaps the ultimate match for our ancient ancestors, rivaling them in everything from tools to culture and even dominance over the land. There was really no stopping this advanced race of ancient hominins. That was until 37,000 years ago, when they all suddenly vanished. But why? This species had everything it took to conquer the earth, So why did they suddenly all die out? What could have caused it? And did we modern humans somehow lead to the extinction of one of the most advanced hominins ever? The extinction of Neanderthals is perhaps one of the most multifaceted extinctions of prehistoric Earth. It genuinely seemed like everything was out to get them. From the climate to other hominins and even their own biology, everything played a huge role in their demise. Strangely enough, the Neanderthals' time on Earth could best be described as an extensive game of dodgeball. However, instead of dodging red balls, the Neanderthals were narrowly dodging extinction. A major reason for this was the climate. See, the climate during their period was much like ours today, only much more unstable. Think about it. Today, the average July temperature in France this year was between 68 to 82 degrees Fahrenheit, or 20 to 28 degrees Celsius. 45,000 years ago, this temperature was not that different, as the average temperature was between 60 to 71 degrees Fahrenheit, or 16 to 22 degrees Celsius. Colder, yes, but the average temperature was still very hospitable. The only problem here was that this average temperature could turn into a cold snap that would last hundreds of years. To make matters worse, it could do this in less than a month, with little to no warning. The climate during the Pleistocene epoch was characterized by frequent and abrupt climatic changes, including glacial and interglacial periods. One example of this cold front was the marine isotope stage, MIS4, which took place approximately 71,000 to 57,000 years ago. Part of the complex glacial and interglacial cycles that have shaped the Earth's climate over millions of years, the MIS4 significantly cooled down the world, leading to the expansion of ice sheets across large parts of North America and Eurasia. Of course, this event quickly had an effect on the environment, as the extensive ice sheets and glaciers led to lower sea levels, as vast amounts of water were locked up in the ice. This cooling phase also brought drier conditions to many regions, affecting vegetation patterns and the availability of resources for both animals and humans. The Neanderthals' MIS4 was a nightmare, as the harsh climate forced them to adapt in several ways to survive. See, normally the Neanderthals were well suited to cold environments, with robust physiques that helped them conserve heat. However, the extreme conditions of MIS4 required even greater resilience and adaptability than they had ever shown. Rising up to the challenge, the Neanderthals developed sophisticated tools and hunting strategies to cope with the scarcity of large game animals, which were their primary food source. But that wasn't all, as they also had to diversify their diet, incorporating more plant-based foods and smaller animals to supplement their nutrition. As with almost all of human history, social cooperation and resource sharing within Neanderthal groups likely played a crucial role in their survival. This is because these communities needed to support each other during periods of scarcity, and they did. Taking things a bit further, the Neanderthals demonstrated remarkable mobility as they migrated to more hospitable areas when necessary. Some groups moved southward to regions with milder climates and more abundant resources, while others took refuge in ice-free pockets known as refugia. Thankfully, these refugia provided relatively stable environments where Neanderthal populations could persist, despite the broader climatic challenges. Another climatic event that nearly took the Neanderthals off the map was the Toba supereruption. Taking place around 74,000 years ago, this eruption was one of the most colossal volcanic events in Earth's history. Originating from present-day Indonesia, this cataclysmic eruption affected the world in ways no one expected, destroying ecosystems and rewriting climates. The eruption released vast quantities of ash and sulfur dioxide into the atmosphere, creating a veil of particles that significantly reduced sunlight reaching the Earth's surface. As you can imagine, the immediate aftermath of the Toba supereruption was a dramatic and rapid cooling of the planet, often referred to as a volcanic winter. This winter caused global temperatures to drop by several degrees Celsius, leading to severe disruptions in weather patterns and environmental conditions. The worst part is that the volcanic winter likely lasted for several years, during which time the Earth's climate was extremely cold, dry, and almost impossible to live in. For Neanderthals, the Toba supereruption event was a frozen hell. The drastic cooling and environmental changes disrupted their traditional food sources. The large herbivores, which Neanderthals relied upon for sustenance, became scarce, as their habitats were altered or destroyed by the changing climate. As usual, the reduced availability of plant and animal resources forced Neanderthal groups to adapt quickly to their new reality. In response to these harsh conditions, Neanderthals made the same adaptations they later made for MIS4. The event was so bad that genetic evidence suggests that the Toba supereruption caused a population bottleneck in both Neanderthals and early modern humans. This bottleneck significantly reduced their numbers, but by sheer determination, some groups managed to survive and eventually recover once the climate began to stabilize. Sadly, you can't always cheat extinction, and one particular event put a nail in the Neanderthal coffin. The eruption of the volcano in the Bay of Pozzololi near present-day Naples, Italy, occurred 39,000 years ago. This eruption was no doubt one of the most significant volcanic events in European prehistory. Known as the Campanian ignimbrite eruption, it released massive amounts of volcanic ash and gases into the atmosphere, causing widespread climatic and environmental disruption. Blocking the sunlight, the eruption sent out a vast plume of ash and pumice that blanketed much of southern and eastern Europe, covering large areas with thick deposits. This ashfall devastated local ecosystems, destroying vegetation and contaminating water sources. The ashes spread as far as Asia, and in many archaeological sites, it has been found to be a divide between when the Neanderthal fossils stop and the Homo sapien fossil begins. But that wasn't all, because a few years later, large glaciers broke the Arctic ice sheets in a Heinrich event that cooled down the Earth even more. Named Heinrich Event 4, the event occurred around 38,000 years ago and was marked by massive discharges of icebergs into the North Atlantic, resulting from the collapse of ice sheets. These icebergs carried and deposited large amounts of rock debris into the ocean, disrupting ocean currents and causing unprecedented climatic cooling. The drop in temperatures quickly led to harsher environmental conditions, further challenging the survival of Neanderthals and other contemporary human populations. Sadly, this time the Neanderthal population could not react fast enough and soon found themselves face to face with extinction. But it wasn't only the climate that led to their downfall, as even their own anatomy had a role to play in their eventual fall. Although very close to ours, the Neanderthal's anatomy is actually quite different from ours. For one, Neanderthals had a robust and muscular build, which required a high caloric intake to sustain. Estimates suggest they needed around 4,000 to 5,000 calories per day, particularly in the cold climates they often inhabited. This made them heavily dependent on large game animals for food. According to estimates, Neanderthals needed almost double the calories Homo sapiens needed. This was a problem, especially during periods of climatic instability, when these animals became scarce and Neanderthals struggled to meet their energy needs. But that wasn't all, as their life cycle was also different from that of modern humans. See, Neanderthals matured faster, reaching adulthood by their late teens. In fact, a 12-year-old fossil found in France was found to have matured as much as a 16-year-old Homo sapiens. To make things even worse, only a few Neanderthal fossils have been found to have lived over 40 years. As you would expect, this rapid maturation left them with less time for extended childhood learning and socialization. They essentially missed out on crucial parts of developing complex skills and social networks, not to mention shorter lifespans, which reduced the period during which they could contribute to their group and transmit knowledge to younger generations. Another thing that worked against the Neanderthals was their habitat preferences. See, Neanderthals were adapted to living in forested environments where they hunted large game. But as the climate fluctuated and forests retreated, they were less equipped to exploit open plains and grasslands, compared to Homo sapiens, who were more versatile and could adapt to a broader range of environments. But by far the biggest problem was their genetic diversity, or rather, their lack of it. See, the Neanderthals had low genetic variation, making them more susceptible to diseases and less able to adapt to environmental changes. As such, small, isolated populations were particularly vulnerable to inbreeding, leading to a higher prevalence of genetic disorders and reduced overall fitness. But that wasn't the only way breeding led to the Neanderthals' demise. In fact, their relations with us played a major role in their eventual extinction. It's important to note that when Homo sapiens met Neanderthals, the species was already reducing in population. See, overlapping in places like France and Spain, we arrived about 43,000 years ago. With us, we brought sophisticated tools, sculptures, music, and of course, competition. Much like the Neanderthals, the first wave of Homo sapiens, the Orogangian culture, preferred the woods. Luckily at the time, there was a small population of both species, and even small interactions, with estimates saying the ratio was 1 person per 1,076,391 square feet, or 100 square kilometers. 6,000 years later, around 37,000 years ago, the Neanderthals were suddenly wiped out. But what did the Homo sapiens do? Well, it boiled down to good old competition, survival of the fittest. Experts today claim the Homo sapiens were better at adapting to colder climates, thanks to tools and technology. But that aside, they were also better at adjusting, especially as they ate a lot of fish and were good fishers. They also had boats, expanded across coastal routes, and sometimes migrated along the routes of herd animals. But that was just one side of the picture, as when we did meet the Neanderthals, our relationship with them led to their doom. See, unlike what you would expect, there is no record of a battle between the two species. However, there is evidence of the two species interbreeding. The earliest known encounters between Neanderthals and Homo sapiens occurred around 100,000 years ago in the Middle East. Fossil evidence from sites such as the Skul and Kavze caves in Israel suggests that both species coexisted in this region for some time. During these early encounters, interbreeding likely took place, introducing Neanderthal genes into the early Homo sapiens population. Shockingly, this gene flow provided Homo sapiens with beneficial genetic traits, such as immune system enhancements, which helped them adapt to new environments as they spread out of Africa. But sadly, it led to the demise of the Neanderthal. After the Middle East encounter, another significant period of interbreeding occurred, around 45,000 to 50,000 years ago, when Homo sapiens began to migrate into southern Europe. Evidence from various archaeological sites shows that Neanderthals and Homo sapiens overlapped in regions, such as present-day France, Spain, and Italy. Genetic studies have even shown that interbreeding during this period led to the integration of more Neanderthal DNA into the expanding Homo sapiens populations. However, this interbreeding, unlike the first one, likely caused the two species to compete for the same resource relationships, including mating. The final significant period of interbreeding between the two species took place around 40,000 to 45,000 years ago in northern Europe. As Homo sapiens continued to migrate and expand their territory, they encountered Neanderthals living in colder, more challenging environments. Meeting at sites such as the Vindija cave in Croatia, this last wave of interbreeding further integrated the Neanderthal genetic material into the Homo sapiens gene pool. In the end, these periods of interbreeding had profound effects on both species. For Homo sapiens, the incorporation of Neanderthal genes provided certain advantages, such as improved immune responses and adaptations to colder climates. However, for the Neanderthals, the consequences were more detrimental. See, the interbreeding and subsequent gene flow contributed to their gradual decline in several ways. As Neanderthal genes were absorbed into the larger Homo sapiens populations, Neanderthals themselves were gradually getting assimilated. This process sadly reduced the number of distinct Neanderthal individuals over time, leading to their eventual disappearance as a separate species. But that wasn't all, because as mentioned before, interbreeding and cohabitation also meant direct competition for resources. Homo sapiens, with their more advanced tools, social structures, and adaptability, often outcompeted Neanderthals for food and shelter. This competition strained the Neanderthal populations, making survival increasingly difficult. Making things worse, this close contact and interbreeding likely led to the exchange of pathogens between the two species. This would have been a problem, as Neanderthals, with their limited genetic diversity, would have been more vulnerable to diseases introduced by Homo sapiens. Finally, although the Neanderthals were capable of innovation, they sadly did not advance as rapidly as Homo sapiens in terms of technology and culture. The superior tools and social organization of Homo sapiens gave them an edge in survival, further disadvantaging Neanderthals. But even though they disappeared, the ever-resistant Neanderthals still found a way to live on to this day. The Neanderthals were first recognized in 1829, but were not recognized by scientists as possible human ancestors until the late 19th century, after the discovery of more fossils. Since then, thousands of remarkable Neanderthal fossils have been unearthed across Europe and the Middle East, representing hundreds of individuals. The earliest known Neanderthal remains were found by Dutch-Belgian prehistorian Philippe Charles Schmeling in 1829 at what we now call the Schmeling Caves in Belgium. There he discovered a child's skull cap named Engis II, along with other bones that left him puzzled. Schmeling thought the bones belonged to a poorly developed human buried alongside extinct animals. Time would pass, and he would soon realize he had discovered a new species of hominin. First appearing approximately 350,000 to 400,000 years ago, the oldest known Neanderthal fossil is the skull fragment called Apodema II, found in the Apodema cave in Greece. This extremely old fossil dates back to around 200,000 years ago, and since its discovery, it has provided valuable insights into the early presence of Neanderthals in Europe. The Neanderthals roamed the earth for quite a while. The youngest known Neanderthal fossils are from the site of the Vindija cave in Croatia. These fossils, dated to around 40,000 years ago, mark the period when Neanderthals were gradually being replaced by modern humans, Homo sapiens, in Europe. Today, the Vindija cave fossils are some of the last evidence of Neanderthals before their extinction. Although Neanderthals disappeared around 40,000 years ago, their legacy continues in the DNA of modern humans. See, even though interbreeding with Homo sapiens led to their demise, it also led to their integration into the Homo sapiens gene pool. Influencing various aspects of our biology and health, modern humans of non-African descent carry about 1 to 2% Neanderthal DNA. Of course, this genetic inheritance varies among individuals and different populations, as it reflects multiple ancient interbreeding events. One significant contribution of Neanderthal DNA to modern humans is enhanced immunity, as their genes provide resistance to certain pathogens. These genes helped our ancestors survive in new environments by improving their ability to fight infections. But that's not all, as the Neanderthal DNA has contributed to traits like skin pigmentation and keratin production, aiding adaptation to different climates and helping early humans survive in diverse environments. But not all Neanderthal genes are good, as while some Neanderthal genes are beneficial, others are linked to modern health conditions like type 2 diabetes, Crohn's disease, and even depression. Studies even show that Neanderthal genes affect sleep patterns, metabolism, and responses to UV radiation. The Neanderthal DNA may also impact cognitive and behavioral traits. Some gene variants affect brain function, suggesting these ancient genes helped shape human behavior and intelligence. A species marked by resilience and adaptation, the Neanderthals are by far one of the most intriguing hominids to ever walk the earth. Living through some of the worst time periods ever, they just might also be one of the most unlucky hominids ever. From global catastrophe to their own anatomy, the Neanderthals' demise was perhaps almost always imminent. However, regardless of their situation, the Neanderthals are proof of just how special we are as Homo sapiens, as we lived through a good amount of these conditions, and perhaps even worse. But unlike our ancient cousins, we managed to pull through and truly conquer the earth. When you picture the evolution of man, it's easy to imagine that every species came briefly after the last one. However, more recent research and strides in evolutionary biology shocked the world, as we now know multiple species of humans lived together at different times and even interacted together. But how is that even possible? What does it mean for the evolution of man? And how did this confusing phenomenon cause different species of humans to breed with each other? In the story of the evolution of humans, perhaps the most fascinating fact is that multiple species of humans with vast differences actually lived together in the same time period, and sometimes even in the same location. See, our earliest ancestors like Australopithecus, Paranthropus, and the earliest known Homo erectus all roamed Africa together, living in places like the Dromoland Paleocave system in South Africa. Their relations with each other were complex and revealed an incredible level of diversity in the nature of our early ancestors. However, it didn't end with them. as if we fast forward to the era of Neanderthals, aka Homo neanderthalensis, and the Homo sapiens, we actually see the same thing occur, but on a more complex and baffling scale. See, these two species at the time of their existence were the focal points of one of the most fascinating chapters in human evolution. According to popular theory, the Neanderthals appeared around 400,000 years ago, primarily inhabiting Europe and parts of Western Asia. They were well adapted to cold climates, with robust physiques and large nasal cavities to warm the air they breathed. But here's where things get really intriguing, because Neanderthals weren't just isolated in their own world. Around 300,000 years ago, the Homo sapiens emerged in Africa and eventually spread across the globe, reaching Europe and Asia, where the Neanderthals already lived. At first, it would seem like science fiction, maybe even a case of alternate dimensions. But alas, it is true, as these two species coexisted in Europe and parts of Asia for thousands of years. To make things crazier, this wasn't just a brief overlap. It was a significant period of interaction, with some scientists dating their coexistence to span anywhere from 5,000 years to 100,000 years. But how do we know this? One of the strongest pieces of evidence supporting the Homo sapiens and Neanderthal relationships is a recent research conducted by the University of California, Berkeley. The research provided compelling evidence that modern humans, Homo sapiens, coexisted with Neanderthals in northern Europe for thousands of years. This discovery, based on the analysis of bone fragments found near Rannis, Germany, suggested that Homo sapiens reached the region around 45,000 years ago. This discovery was quite jarring, as it showed that their arrival significantly overlapped with the time Neanderthals inhabited the area. The strangest part of this is the fact that this coexistence presents a fascinating chapter in human history, revealing complex interactions between the two species. See, shocking everyone, the study confirmed that Homo sapiens and Neanderthals lived in the same regions for several millennia. So much so that their extended period of coexistence provided numerous opportunities for interaction, ranging from competition and cultural exchange to even interbreeding. Yep, ancient Homo sapiens and Neanderthals got it on, and we know this thanks to the presence of Neanderthal DNA in the modern human genome, which is basically due to the genetic intermingling that occurred during this time. To make things more fascinating, research has shown modern humans outside Africa carry about 1 to 2% Neanderthal DNA. But that's not all, because Neanderthals weren't just distant cousins. They were incredibly similar to us, with a DNA similarity of 99.7%. Essentially, they were even closer to us than chimpanzees, our closest living relatives, who share 98.8% of their DNA with us. Ultimately, the presence of Neanderthal DNA in modern humans today supports the idea that these two species were not only neighbors, but also partners in a shared evolutionary journey. Besides genetics, the study also took a look at the Rannis site, renowned for its intricate leaf-shaped stone tools, and found it to be an early location of modern human activity in Europe. The Neanderthals were skilled toolmakers, creating sophisticated tools known as Mousterian tools. However, when Homo sapiens arrived, they brought their own advanced tools and techniques, such as the origination tools. The discovery of these tools, once thought to be the work of Neanderthals and now attributed to Homo sapiens, ultimately revealed that these two groups even shared technological innovations, suggesting a level of interaction that goes beyond mere coexistence. The technological overlap suggested that there might have been a transfer of knowledge and skills, and even a level of cultural exchange between the two species. This cultural exchange is highly possible because the Neanderthals had complex social structures, used symbolic objects, and possibly even had forms of language which might have been influenced by the Homo sapiens. This interaction essentially shaped a dynamic and unpredictable relationship that would ultimately set the tone of the nature of human evolution and the intricate web of our ancestry. Knowing now that the two species have been together for thousands of years, the question is, what would a child between the two species look like? Let's find out. The love relationship between the Neanderthals and Homo sapiens is actually a tragedy. This is because, try as they might, the chances of creating a Neanderthal sapiens child were extremely thin, and it was due to a flurry of reasons. One of the primary challenges to producing viable offspring between Neanderthals and Homo sapiens was genetic compatibility. See, although they shared a common ancestor, Neanderthals and Homo sapiens evolved separately for hundreds of thousands of years, leading to notable genetic differences. These differences led to various issues in hybrid offspring, including reduced fertility. For example, studies have found that certain Neanderthal gene regions are notably absent or underrepresented in the modern human genome. In fact, the segments on the X chromosome in particular show a significant depletion of Neanderthal ancestry. As such, they suggest that male hybrids who inherit an X chromosome from their mothers and a Y chromosome from their fathers might have been less fertile or even infertile. This was a huge problem, as it reduced the chances of these genes being passed on. Another intriguing reason why they could not reproduce lay, once again, in their biology, as there was an alarming incompatibility between their Y chromosomes. This often led to reproductive challenges and miscarriages, where Neanderthal males mated with Homo sapiens females. Despite their close genetic relationship, the Y chromosome in Neanderthals, which is passed from father to son and contains crucial genes for male development and reproduction, had certain mutations that were not present in Homo sapiens. These mutations led to issues during interbreeding. Essentially, when a Neanderthal male and a Homo sapiens female mated, the immune system of the Homo sapiens female often recognized these mutations as foreign. As such, it triggers an immune response aimed at protecting the mother from what her body perceives as a threat. Unfortunately, this immune response frequently results in miscarriages, a phenomenon known as hybrid incompatibility, where genetic differences between species cause reproductive issues. Beyond genetic factors, social and behavioral barriers likely played a significant role in limiting interbreeding between the species. See, Neanderthals and Homo sapiens had different social structures, communication methods, and cultural practices, and these differences could have created significant barriers to successful interbreeding. For instance, distinct mating behaviors and social bonding mechanisms might have made sustained interbreeding challenging. Not to mention competition for resources and territorial disputes might have further limited interactions between the two groups, thus reducing opportunities for interbreeding. The extinction of Neanderthals around 40,000 years ago is a multifaceted phenomenon that likely involved several contributing factors, one of which was hybridization with Homo sapiens. See, while hybridization itself was not the sole cause of their demise, it played a crucial role in a broader context of ecological, genetic, and competitive pressures. So much so that one of the leading theories is that Neanderthals may have been genetically swamped by the larger population of Homo sapiens. Essentially, as Homo sapiens migrated into Neanderthal territories in Europe and Asia, their populations grew and interbred with Neanderthals. Now, given that Homo sapiens had larger and more expanding populations, the gene flow would have been predominantly in one direction. Over generations, this could have led to the dilution of Neanderthal genetic identity, as their genes were absorbed into the larger Homo sapiens gene pool. This effectively caused Neanderthals to be genetically assimilated. Hybridization also likely led to reduced reproductive success for Neanderthals. As mentioned earlier, genetic evidence suggests that male hybrids might have had fertility issues. This reduced fertility could lead to a lower reproductive rate among Neanderthals, as more of their offspring were hybrids with lower fertility. This would contribute to a declining population over generations, eventually leading to their extinction. But that's not all, as hybridization might have also exacerbated the competition for resources. See, you have to remember that Homo sapiens and Neanderthals occupied similar ecological niches and relied on similar resources, such as large game animals and plant foods. With the arrival of Homo sapiens, who may have had more advanced technology and better social cooperation, Neanderthals definitely faced increased competition. As such, the interbreeding between the two groups could have led to Neanderthals being outcompeted for resources by the hybrids, who might have had a survival advantage due to a combination of Neanderthal and Homo sapiens traits. Besides external competition, the Homo sapiens had more advanced tools and cultural practices compared to the Neanderthals. And with these advantages in technology and social organization, the Homo sapiens might have had a significant edge in survival and reproduction. Eventually, as interbreeding occurred, Neanderthal populations might have struggled to compete culturally and technologically. leading to a decline in their population over time. Not to mention hybrids with better tools and social structures would have had higher survival rates, further contributing to the decline of pure Neanderthal populations. But their troubles didn't end there, as the migration of Homo sapiens into Neanderthal territories likely brought new diseases to which Neanderthals had no immunity. Of course, the hybrid offspring might have had a better immune response due to the mixing of genetic traits from both species. But this would also mean that Neanderthals, without interbreeding, might have been more susceptible to these new diseases, leading to higher mortality rates. In the end, this increased susceptibility could significantly reduce Neanderthal numbers, while hybrids and pure Homo sapiens populations continued to grow. Although the chances of having a child were extremely slim, and it led to the end of the Neanderthals, the relationship is not without its wins, as it plays a major role in our lives today. The interbreeding between Neanderthals and Homo sapiens has had a profound impact on modern humans. This is thanks to the integration of Neanderthal DNA into the human genome. This integration has influenced various aspects of our biology, health, and even evolutionary history. One of the primary effects of Neanderthal interbreeding is the enhancement of genetic diversity in modern non-African human populations, which carry about 1 to 2% Neanderthal DNA. This genetic diversity has added complexity to the human genome, influencing traits and enhancing the adaptability of Homo sapiens to different environments. For example, some Neanderthal genes affected keratin production, which impacts skin, hair, and nails, likely helping early humans adapt to colder climates. Surprisingly, that's not all, as genes related to the skin's ability to handle ultraviolet radiation, which influences pigmentation and vitamin D synthesis, are inherited from Neanderthals. Moving on to our overall health, the Neanderthal DNA has significantly impacted the human immune system profoundly. This is because certain immune-related genes inherited from Neanderthals have been linked to the body's ability to recognize and respond to pathogens. This has had both positive and negative consequences. On the positive side, enhanced immunity to certain pathogens helped early Homo sapiens survive in new environments. On the negative side, these genetic traits also increase susceptibility to autoimmune diseases such as lupus, Crohn's disease, and type 2 diabetes. Moreover, Neanderthal genes influence susceptibility to various conditions, including depression, nicotine addiction, and even skin disorders. Physical traits in modern humans can also be traced back to Neanderthal ancestry. These traits include certain facial features like brow ridges and the shape of the skull, although these traits are generally subtle and vary among individuals. Additionally, Neanderthal genes have also been linked to metabolic processes in modern humans. For instance, some Neanderthal alleles affect how our bodies process fats and sugars, which might have been advantageous in the past, but could influence the risk of metabolic conditions today. Their influence doesn't end there, as they also have a serious influence on modern human brain function and cognitive abilities. According to some studies, Neanderthal genetic variants might affect neurological development and brain structure, potentially influencing behavior and cognition. Though they are long dead, the legacy of our ancestors and their relations has a large impact on who we are today and who we as a species may become in the future. From health to our way of life, their interbreeding created the framework of who we are today. But what do you think about this ancient love story? Let us know in the comment section. And while you're at it, why not hit the like and subscribe button to learn more about the past? Until next time.